Welcome back to Advent of Code 2024, day 4. So starting a little bit later this time. Okay, let's begin. Day 4, Ceres search. Okay. Looks like the chief's not here. Next, one of the historians pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the Ceres monitoring station. This is from 2019. I did this one recently, actually, so yeah, I remember this. As the search for the chief continues, the small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with her word search, your puzzle input. She only has to find one word, Xmas. Hello, Amaro. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual though, as you don't merely need to find one instance of Xmas, you need to find all of them. Here are a few ways Xmas might appear, where irrelevant characters have been replaced with dot. In this word search, Xmas occurs a total of 18 times. How many times does Xmas appear? Okay. Okay. So this isn't particularly difficult. I think we want a method that takes a list and finds how many Xmas's are in that list. Then an outer method, which is just passing lists to this method horizontally, vertically, and a diagonal. So, yeah. Let's copy the input in. Or we could search the input by hand. Somebody's done that, I'm sure. All right. Let's say word search equals just an array. We'll put lists of a list of strings, let's say. So let's copy this here. So with input for line in f.read lines, we just do word search dot append line dot strip. Okay. So for a given list, a given string, let's say, actually cast this to a list. It'll be easier to iterate diagonally and stuff. All right, so we've got a list of lists of characters. Um, so count Xmas for a given list, or a given iterable. It could just be a generator, I suppose. No, we want it as a list because we want to be able to access indices. So let's say for I in range length L minus 4? Yeah. We want to say if L from I to I plus 4 is the same as Xmas. Not quite. Dot join reads Xmas. Results plus equal 1. Return results. So that counts how many Xmas is in one line, regardless of direction. Okay. Okay, let's make one new method. Define get lines given a matrix. All right. So this is going to get all the lines as lists, and let's say we yield them using yield. So it's basically a generator that generates lines. You just solve part 1. Nice. So let's say start with horizontal. Should we just do both Xmas and Samx in one, rather than get the backwards line? That'll save us one line of that'll halve the amount of work technically. All right, let's do that. If join in, so it checks if it's Xmas forwards or backwards. Then we don't have to get the backwards lines, so we can say no, that's not what we do. Bad. You have to add one for each, obviously. Okay, horizontal. Let's say for I in range length of the matrix. Yield mats. Alright, that's the easy one. Vertical for J in range. Can we just oh, okay, so n equals length of the matrix, m equals length of the first row, so this is the width. So this is n. J in range m. yield. We want mat I j for I in range n. And then diagonal yield, so it's going to be mat I. It's a square matrix. It has to be square. So get rid of that. And we have to yield the other diagonal, so it's going to be n minus I. Nope. N minus I minus 1. So 0 will be paired with n minus 1. Yeah. Okay. That's it. Get lines. All right. So the actual calculation... it's quite simple at this point. It's just print sum of map. So we map Count Xmas to should just be get lines word search. That's an iterable, right? Eight, 7, 6. It's easy to miss something for this problem. Let's see. Not correct, too low. Okay. All right. So let me just read this again. Even overlapping other words. We should have accounted for that because we are doing each value of I. Backwards. Yeah. Should be covered. That should be covered too. So are we doing all the lines? All right, we'll test the small case then. So we should get 18 for this. Seven. Should be 1 in the first row. All right. This one was a bit confusing, to be honest. And part 2 is worse. Okay. Well, the description seems straightforward to me, so maybe I'm missing something key about the... We can... Okay. We can try printing... Oh! all diagonals. Yeah. That was me assuming they're talking about the diagonal. No, all possible diagonals. Okay. Okay. So diagonals diagonals going down, let's say, just the easiest way to describe it. So we want for j in range n, we want to yield the row which starts at 0, j, goes downwards to j0, 0j to j0. So it's going to be mat So it's going to be mat j No, j is not I, j minus I, or I in range j. It's only j length. Was it? Yeah. So for j0, hang on, no. Sorry, n minus j. So for j equals 0, we want the big diagonal. Hang on, this is just the upper triangular diagonals. Oh god. Okay, yeah, I see why this is confusing now. No, we want all diagonals. Okay. Maybe an easier way to think about this is every diagonal starts or finishes at one of the horizontal edges, one of the vertical edges. So we just go through every point on the left vertical, every point on the right vertical, throw two diagonals from those points. Then we just have, yeah, but that also means we double count the main diagonals. I don't know what the cleanest way of going through all the diagonals is. I mean, this thing that I've done here is fine. It's just this is the top right triangle. We need to do the bottom right triangle. So maybe, I mean, we could do it that way. So j in range n. So let's just make sure this is correct if that's what I'm trying to do. J. So for example, for j equals 0, that means that we want the big diagonal. So it'll be mat I What? Oh, this is wrong. No, not j minus I. Be n minus j. No. So j equals 0. We start in the 0 column. So the column will be 0. For j is 1, we start... Yeah, so it's j. Plus I guess. J plus I. Yeah. Yeah. Wait, so that goes to n minus j. All right, I think that's right. So then if we want the same thing, if j is not equal to 0, because otherwise we'll be double counting, yield I plus j I. So this way we go. So for example, I equals so I is 0. Sorry, so if j is 1, say, I need to draw a diagram here. J is 1, we're going just above the main diagonal, but we also want just below the main diagonal as well. Just above the main diagonal, j equals 1, so we start from 0, 1, correct? And then we add 1 each time until we get to n minus 1 minus 1. Yeah, that's right for that. And then for the other line, it's simply going to start from I equals j. Yeah, we're saying j equals 1, so we're starting from the I value being 1. Yeah, that's right. It's a bit confusing because I am normally using for rows and j am normally using for columns, but here it's not actually, that's not actually what it means. I should have used like k's and, I don't know, some other value. All right, so that's diagonals going down. Diagonals going up should be something similar, I guess. There's probably a better way of doing this using slicing, just using the fact that if we just consider it being on an infinite grid and restrict lines to, I don't know, whatever. Diagonal's going up, so it should be something similar to that. But instead of this should just be what, n minus I minus 1? Oh, this is so confusing. I should have got some paper. Let's see if I can finish this. Otherwise, I'll get paper out and write this out properly. So the n minus 1, n minus I minus 1 for the I value. And the j value will just be the same as before, so you just add 1 each time I is increasing. Yeah. No bad cop. Yield. Are you not a fan of yield? Well, that seems right. What was the next line? J. So we start from do I just swap these around? I don't know. Just run that and see what happens. 13. Not quite. Wait, what's this? Oh, get rid of that. 13. Almost. Alright, I just realized a better way of doing this. A way better way of doing this. Can we finish it off the way I'm doing it though? N minus I minus 1. Alright, screw it. Let's do it the better way. Alright, so the better way, I think, is just go over every individual grid cell and just go in all directions, 4 spaces. And only the ones which we stay in bounds when we go for spaces, those are the ones we actually evaluate. It's the same runtime because you're going through all items in the matrix like once. It's like linear in the size of the matrix. So yeah, this. Let's forget this. Forget we ever did this. Start again. Yeah, this is so much simpler. So, okay, so we say for I in range, wait, so n equals length of word search. Let's just move all this down here. We'll delete it soon. You can do some branch trimming this way if you want to be efficient. Yeah, maybe. Well, for part 1 at least, it should be pretty fast. Should just be the same amount of time it took to write the matrix in the first place, I guess. Okay, n equals length of word search for I in range n, for j in range n. Say there's 8 possible deltas for delta in or I don't know, just say for delta I in -1 to 0, 1, or delta j in -1, 0, 1, if j is equal to 0, example, mine only scans a cell if it has an X. Oh, yeah, okay. Yeah. That's an easy optimization to make. Probably do that. Continue. Okay, so for this direction, we want to say endpoint equals I plus di 4 times di, j plus 4 times dj. Let's make a quick method here. Define is inbounds I j return 0 is less than or equal to I is less than n, and okay, let's say if is inbounds those two values, then we have a segment that lies in the matrix. So now we can say the string, let's say, just write it out fully. Mat okay. Okay, just do it like this. Mat I plus K times di j plus K times dj for K in range 4. I'm guessing that part 2 is going to involve arbitrary word sizes as well as maybe some other twists. If that is Xmas result plus equal 1. Okay, yeah, this is a way better approach conceptually, and don't have to worry about all these lines. Alright, let's see if it works. Matt? Okay, yeah, word search. 17. One off. No, it should be 3 here. We're going too far. There we go, 18. Yeah, we can put that optimization in. We can say if word search ij is not equal to x, continue. $18. All right, yeah, way better. Now we need the big one. 2560. Yeah, 876, that was way too low. Correct. Part 2. The elf looks quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find that this isn't actually an Xmas puzzle, it's an Xmas puzzle, in which you're supposed to find 2 mus in the shape of an X. One way to achieve that is like this. Alright, I'm glad I changed to this approach, because I feel like this approach is much better suited for what we're doing here. Irrelevant characters. Yeah, the last approach was unusable for this. Irrelevant characters have again been replaced with... within the X, each mass can be written forwards or backwards. Xmas. It's like XCOM versus XCOM. XCOM was the original. XCOM without the hyphen. No. Which one was the first XCOM? First XCOM was without the hyphen. The new XCOM is with the hyphen. This is the silly version of my part 1 solution. Alright, probably have a look at the end. Okay. So basically for each A, We want to look on each of those diagonals and check if it's a Mass or a Sam. Yeah, okay. The logic seems okay for this, the way we've written it so far. Flip the word search from the instructions back over to the word search side. What does it mean by that? Oh, it's saying because it's like the elf had a piece of paper and he flipped it over. Okay. We're just using the same input, right? Yeah. Yeah. Okay. Yeah, I'm a bit confused about what the elf would be seeing on the other side of the page. If it's the same word search, what? Or maybe there's just like a paragraph which says you're looking for a Mass or something, I don't know. Oh, he's talking about the instructions. I guess there were more instructions on the back of the sheet of paper that he's holding. Okay. Alright, yeah. So, yeah, this actually doesn't seem so bad now that I've written it this way. So, part 2. So, similar approach here. Just take most of this, I guess. Just rewrite it. So for I in range n, for j in range n, we can check if it's an A. Alright, for dij, so we don't need to do this. We just need to say check if is inbounds. We want to check is inbounds the four corners. If is inbounds I plus 1, j plus 1. Or just so we don't have to indent so much, to say if not is bounds. Continue. So we've got I plus 1 plus 1. For this one, I'm just finding every A and checking if it's in the right shape. Yeah, that's essentially what I'm going to do. And that sounds like the right way to do it. So my original attempt at part 1 didn't exactly lend well to this. Okay, so we know we're inbounds. We know we have room for the shape. So if so I can just write this out like if word search I minus 1 j minus 1 plus word search I j plus j I plus 1 j plus 1, so that should give us a string, is in either Mass or Sam. I mean, technically, we don't need the middle part. Okay. I mean, we're actually just trying to do this. If this tuple is in either M, S, or yeah, it did actually look better when I added them. Doesn't matter. And okay, no, just say if not, continue again. And if not, so I +1, J -1, I -1, J +1. Continue. So result, and they're unique on the center. So we just add 1. Okay. (1910). You would expect it to be less common than Xmas in general. I'd have thought it'd be far less common, but then, I mean, it's not random. This has been devised, so let's see. Correct. All right. Yeah, that was a good problem actually. Definitely encourages you to think carefully about how you're iterating. Using deltas like this, I always find is makes it a lot cleaner and easier to avoid making mistakes. So yeah, and I mean this is computationally as efficient as it gets. I mean it's linear time in the size of the matrix. Yeah. If you had arbitrary word sizes, then you might want to go one letter at a time and stop as soon as it doesn't match Xmas. That will avoid. Otherwise, it's cubic time, isn't it? If a word could be as long as the word search itself, then every time for every cell in the matrix, you're checking a whole linear time. Well, it's still cubic time, but it's just more output sensitive if you cut early. My silly solution runs 10 times faster than my efficient solution. Computers make no sense. I guess sometimes there's just a lot of optimization happening behind the scenes with a certain language. That enables it to recognize certain patterns, and I don't know. I've seen that happen a lot for C++ when I was teaching it, so I had to tell my students to actually turn off optimizations because we were trying to analyze complexity, and it screws up our analysis if the language is doing clever optimizations to save a lot of time. Hang on. So let me take a look at the link you gave me. So this was Okay. Well. Okay, yeah. That's somewhat more understandable to me than I was expecting it to be. At least when we get down to here. But yeah, I don't understand a lot of this, but okay, so you were doing basically my first approach. I'm sure my approach would have worked, but yeah, I was just getting the indices wrong. I guess indices are not relevant here because it's sort of implicitly bounded by the it rotates the grid 90 degrees. Oh, okay, yeah, that's good. Yeah, that's actually a good way of doing it. Transpose and rotate. Cool. P1 to SH. Okay, yeah. Yeah, these first few days have been good warm-up problems. There haven't been any huge tricks on them. Usually they're just about getting certain techniques right, which are actually pretty useful techniques in general and for problems to come. Hello, Smab UK. Let's have a look at this. Your bad solution. So, is this going by lines like I was doing originally? Corners. Oh, this part is the cross stuff. Okay. Yeah. Diagonals southwest as strings. That's a nice method name. Okay, cool. It could be around time for Captain Coda to be on. Is he? No, doesn't look like it. Alright, just have a quick look at stats and then I'm done. Leaderboards, day 4. Fast, as always. Yeah, I mean, these 4 days, it's like that. It's pretty plausible that the top people are always gonna do it within a minute or so. Apart from that, but that was a cheating instance, which I'm surprised they've left that on the board. I assume it would get removed at some point. Yeah, leaderboard. Normally too early for him. Oh yeah, it's usually within an hour, probably. And oh yeah, leaderboard, private leaderboard. Cool. It looks like some new people have joined my leaderboard. Captain Coda's leaderboard. Maro, you've done this as well, have you? Yeah. Okay, yeah, nice problem. Yeah, not much to say about that algorithmically. Just get your indices right. Get your for loops right. That's really all it was. A bit of practice with for loops and indices. But yeah, what I was saying earlier, for arbitrary word sizes, it would be cubic. So you could actually come up with a problem for which algorithmic complexity is an issue. You could look onto building, like, I don't know if that will help, like the tries, TRIE, for... No, you wouldn't need that really. Just cutting off early when you realize the word doesn't match should cut down the linear time most of the time, but you could construct a counterexample which would take cubic time, but from general inputs, it should bring it down to quadratic. Yeah. Alright. Thanks for watching. I don't know if anyone's doing AppleTip code now. Kuvi Man, I raided him the other day. Who's this? Alka.
Clear.
JavaScript.
Yeah, origins. I don't super love my day 4 solution. It's pretty messy.
Alright.
I shouldn't have done it.
Oh,
But it worked.
that cop's in there as well. Okay. Let's raid Alka then. I just saw the p1.sh there. Alka. The username's just Alka. Oh, it is. Okay. Alright, thanks for watching, and go check out what Alka's up to. Bye-bye.